Thanks, Brandon. Okay, I think we've got enough of looking at my illustrious career here. So let's move on to the presentation. I'm Mike Dalton. I am with Siemens Industry and particularly with the Industrial Identification Group. So we're involved in identifying and locating, whether it's using RTLS, which we're going to talk about today, or RFID as an alternative technology. Both of those technologies are used for, these are some of the applications that they're used in. So smart applications in manufacturing, everything from production control, work in progress, logistics applications and warehousing, and tracking and tracing of assets and materials as they move through the production floor or in and out of inventory status. We also can do people tracking, and that pertains to safety applications, service and maintenance applications. You want to know where people are they in the right place? Did they spend too much time in a certain area? So tracking their efficiency and so forth. Certainly safety, if they're drifting off into a hazardous area, it would be useful to know that, or if they can only be in a certain area for a limited amount of time, we do that sort of tracking. We also do access control, simply giving personnel access to certain areas, whether it's a workstation, a prohibited part of the building, etc. And then finally, with RTLS, we've developed an algorithm to use for social distancing. Since COVID is kind of on the downswing at the moment, it may not be used particularly for social distancing, but we can set up parameters for how long people are together, and at what distance, and then alert them that they're in violation of a social distancing scenario. So when COVID-20 comes around, we'll be ready for that one again. But the same infrastructure you set up for RTLS to do that social distancing tracking can at the same time be used for other types of tracking, so it's not a wasted investment. And then finally, vehicle tracking. So RTLS is very useful in fleet management, bus depots, light rail depots, those sorts of things, both from the standpoint of making sure the vehicles are aligned in sequence for the next day's run, or things like access control into the yard and those sorts of things. So these are some of the things, the main areas where we see RTLS being deployed today. Certainly, if you have any questions, by the way, as we go along, don't necessarily wait for the end. Go ahead and let us know and jump in, and we can, or signal, and we can take your question. This is our entire portfolio for industrial identification products, and it includes optical ID, radio frequency ID, and of course RTLS, which we're going to talk about today. I'm not going to spend a lot of time on the other categories, but we have more than one approach to identifying and tracking assets per your application. The main difference between optical, RFID, and RTLS is the fact that optical is involved with a camera, obviously. RFID is involved with radio frequencies in the HF and UHF frequency band and uses transponders or tags, I'll kind of use that term interchangeably today, that are not powered. So they're a passive RFID tag versus RTLS, where the transponders have a power source and use different frequency bands to give you accuracy down to a 1 foot granularity, if that's what you need, if that's what you're trying to track through your facility. So RTLS is really a perfect extension of what we were doing with SIMATIC ident in the form of OID and RFID. And the difference is it's not only telling you what the asset is that you're tracking and when it maybe came by a certain point, say on a production line or through a facility, passing doorways, etc., but it also tells you where that asset is at all times. And again, down to a specific resolution that's determined by what you need in your day-to-day operations. So let's jump into a little bit more of the details on RTLS. And this is kind of what the system looks like. It consists of a set of gateways that are strategically located in your facility, typically hung from ceilings or mounted on walls or poles to provide omnidirectional RF coverage out of that gateway and make sure that every spot that you want to have covered and track assets through is covered with an RF signal. The gateways are getting signals from and communicating with the transponder. This is one version of our transponder, and we'll show others later, but that has a specific ping interval set up. And the ping interval is set up depending on how often your object moves, how often you want to take a reading at the gateway, as to where that transponder is located. The three gateways will triangulate the transponder location and provide or pick up XYZ coordinates from the transponder. And then using some math and working at our head-end server through our software, that's where we determine where the transponder is located, again, with that down to 1 foot accuracy. But it all depends what you need for your application. Obviously, if you're doing buses in a bus yard, you don't need 1 foot resolution when you have a 20-foot long bus. So it's the number of gateways and is in large part determined by the size of the facility and the resolution that you're trying to achieve. The data that is gathered at the gateways is sent up to a head-end server, and these are the other components involved. So you have that infrastructure layer that I was just talking about with gateways and transponders mounted on the assets, whether they're forklifts or crates or bins or any kind of vessel or something like that, and then pinging the gateways. And the XYZ coordinate TCP/IP information is provided to the locating manager. That's the head-end server. Locating manager is the base level of software that we can provide in that head-end server. And then we have software options, another higher options called location intelligence. We'll differentiate between those in the next few slides. But that's where the smarts of the system are, and everything comes back to the locating manager. The next step, the higher up step, is IT integration. So what sort of systems do you have existing in your facility and do you use on a day-to-day basis that we'll have to interface with? That can sometimes take some IT integration work, either via your own IT folks or solution partners that Siemens can recommend for that. But all that information is then sent up to your higher level system and translated into the information that you might need for daily reports, etc. The gateways are PoE devices, so typically powered by PoE. If you cannot power one by PoE, we can use an AC adapter, and the gateway in that sense that is not connected directly to Ethernet can speak to the other gateways wirelessly and in a mesh topology. So you can have a mix and match of some that are PoE powered, some that are wirelessly connected to the other gateways. The fastest, the best in terms of latency, because we are talking about RF here, would be to have them PoE connected for the fastest and lowest latency between gateway communication. Generally, we start out with what we call a device plan, and this determines where to place the gateways. This facility you're looking at happens to be a Siemens facility in Houston, where we're using our own product for the social distancing application I mentioned earlier. So it's fairly dense. There's a lot of gateways. And those are exactly located by means of a site survey. But there are variables that determine how many gateways need to be placed in a facility. Number one is the resolution needed, as I said. You might need 1 feet, you might need 3 feet, you might need 10 feet. The lesser the resolution, the fewer gateways, obviously. It also depends on the technology used. The FCC does govern which frequency bands to use, both indoors and more outdoors. I'll say they restrict which frequency bands you can use. And in an indoor scenario, you use a combination of frequencies in the 3.5 gigahertz band, 3.54 gigahertz band, 2.4 gigahertz, and 6 gigahertz to do that triangulation and get the higher resolution. Outdoors, the FCC says you can only use 2.4 gigahertz. And In using 2.4 gigahertz only, you're not able to achieve that 1 foot resolution. The best you can do is about 3 feet or so. The gateways themselves have all the frequency options in them. There's not a different one to use outdoors versus indoors. It's simply a matter of configuring for ultra wideband use, the indoor application, versus outdoor use at 2.4 gigahertz. Other factors that would determine the number of gateways could be, you know, do you need the whole facility blanketed, and are you tracking through the whole facility or just certain parts of the facility? Or are there primary areas where you need a higher resolution of tracking versus other areas, say out in a warehouse and so forth? So that kind of determines the number of gateways, and it's useful initially when you're speaking about an application to obtain a copy of the site plan, and we can very quickly, after having the discussions about resolution, etc., determine how many gateways you need, give you an order of magnitude of the cost of the system. Is this going to be $50,000 or $200,000? So it's a good way to get started and to get a gut feel as to what an RTLS system is going to cost. Here's a picture of that same facility where the gateways are deployed. There you can see these red circles. Sorry, it's not real clear, a little grainy, but you can see them hanging from the ceiling in most cases or mounted to these side posts. Again, this was a fairly dense deployment because we're tracking to a higher resolution, and we also have issues at this facility from time to time as these equipment shelters are being constructed. There are times when this whole factory floor can have a dozen or so of these buildings, and what are they made out of? Metal and so forth, and have a high degree of reflectivity for RF, as well as potentially blocking line of sight. Ideally, when we locate these gateways, we are planning for doing what we need to do to get clear line of sight. So again, there's a lot of them in this building because there's oftentimes a lot of these equipment shelters providing obstructions and so forth. But that's what it looks like. These are all PoE powered, so Cat5 run to all of them. And that's the idea of how it looks when it's deployed. These are the components of the system, another way to look at it. So we have transponders that I mentioned, powered transponders. The small black one you see here is about 3 inches by 1 inch by 1 inch. It uses a CR123 sort of camera battery. The LCD screen versions, where you can change information on the screen and give you current status in a visual context, are rechargeable batteries. So they have a docking port that you put them in occasionally to power them back to full power. Then there's a version of the transponder that's used for mobile applications with forklifts, AGVs, the buses I mentioned, the trains I mentioned. That transponder is powered by the vehicle power. For the battery-powered transponders, battery life is dependent on how often that ping interval's been set up. But generally speaking, you can expect a worst case 6 months and best case a couple year type of lifespan out of a battery before it needs to be charged. But again, if it's in a, let's take the example of the Siemens facility with social distancing, we're pinging quite often. So they use the smaller 3-inch LCD screen transponder, and those need to be charged probably every couple of weeks or so because of that application. The gateways, again, they're one type of gateway with all the frequency options contained in it, but that's the access point, if you will, that accepts the communication from the transponder and then sends it up to the head-end server that contains the location manager, location intelligence, and other software that can be used at the head end that we'll talk about in a minute. So everything comes back to location manager, and that's the point where you integrate to your existing systems. This is a look at the data, the raw data that comes back to the head end server and allows you to do with it what you will. So you can see what's being provided here, tag ID, localization data in XYZ, the timestamp, a battery status, all things that you'll want to pull into your MES to provide you the meaningful information you need on a day-to-day basis. I mentioned the software options. Let's go into that in a little more detail. So the base level of software used at that head-end server is called Location Manager. It gives you visualization over the site plan that can be imported from your facility and shows you where a transponder is located and how it's moving through the facility. Pretty basic level stuff, but it's necessary for any higher level software that you're going to be using as well. The next level up from Siemens is called Location Intelligence, and this provides the interface to the MES system. It gives you more analytical capability of the data, processes events, gives you a nice dashboard look, and allows you to, in a user-friendly format, configure your tags and assign orders, or we call them orders. It's assigning the duties of the tag, naming the tag, and setting up the parameters of the tag. It also gives you the ability to geofence, which is pretty important when you're doing RTLS, because you want to designate certain areas that provide the transition as a tag moves around the facility. So you can name those geofence areas, set up alerts and alarms as to when transponders enter and exit, and that's all done through Location Intelligence. A new development that's just come out in the newest version of Location Intelligence is an easier way to program process flows. And we use Node-RED, an open source programming capability to do that. It's a tool to kind of drag and drop and provide that a more streamlined interface to the MES. So a lot of people can do that on their own now using Node-RED versus maybe using a solution provider of ours to do the integration. But if you're familiar with it, it's a nice add-on to Location Intelligence. We also have the social distancing algorithm that I mentioned. That's an add-on software called C-Trace. That's available. And then we have a third-party partner called Chasm that provides a product called Locera. Pretty much does everything that Location Intelligence does as well, but also gives you the ability to reside in the cloud, have your whole system reside in the cloud, which might be interesting if you have multiple facilities and you want to be able to toggle back and forth quickly between the facilities to locate transponders and so forth. The other difference with Locera in being cloud-based, it's a monthly fee, and they're pretty flexible. It can be set up as monthly, 6-month, or yearly contracts based on the number of transponders, and pricing varies depending on clearly on the number of transponders. They do require an edge PC device, plus again our mandatory Location Manager base level software to work. Another nicety with Locera is that they have also incorporated the ability to keep record of RFID tags that are going through the facility at the same time. So you might have a mix and match of RFID and RTLS. And the nice thing about Locera is you've got a dashboard that can show you both at the same time. So those are the options that are available for software, and pretty much depend on what it is that you're trying to do for your specific application. Almost every RTLS project that we're involved with is a little bit different. So we have to have a number of different approaches to doing things. And that's something that we can discuss with you to best determine which works best for your application. Another way to just kind of look at these, the visualization approaches is when you categorize them into Location Intelligence, Locera, and then some fancy customer specific one that a solution partner would do. So again, just bullets that we kind of just talked about for the 3 versions. Each do certain things best, and it's nice to have options. This is I mentioned Node-RED and the ability to drag and drop programming for visually drag and drop programming for what you want to do through RTLS. And this is kind of what it looks like. I have to claim a bit of ignorance on it because it's so new, but I'm told it greatly eases the programming and setup for RTLS, as well as the integration up to those existing systems that you might have. If you have an interest in learning more about this, we can certainly set up a more technical based educational webinar on what we're doing with Node-RED, but it's a nice development for us. As far as the dashboard look at location intelligence, even this is a little bit dated in this picture, but you can see it's a nice user-friendly dashboard that gives you some great information, everything from battery life of a particular transponder. Certainly in the lower right-hand corner here, you see this would be a live operation of the RTLS. These blue squares are the gateways, and with tags start moving around, you can see them move through the facility. You can click on that site plan, and it'll expand to the whole screen. You can click on specific tag IDs here to get further information and configure. You can see how many tags are in operation, how many are in standby, who needs to have their batteries charged. You see a list of the notifications that are happening. Perhaps you want to keep notifications on which transponders are in which geofence. So that sort of thing shows up on the dashboard. And with the new version of location intelligence, off here on the left is another way to quickly access different sections of the dashboard, and it adds a lot to the GUI interface. So a good dashboard look. Some other of the screens that you can click through when you're selecting and creating these orders and assigning a transponder to a particular order, naming it whatever you want to name, looking at the tag IDs, the battery status, which tags are free, which tags are assigned. So you get a constant status on what's happening in your facility and how many tags are where and in operation, etc. This is kind of how it would look on the screen. So again, the blue squares are the gateways. The blue circles are the various transponders with real-time location. And the colored shaded areas are the geofenced areas that you've set up. So again, a nice look at what you'd see with location intelligence. And very similar with Lacera. They have a dashboard that's a very nice look as well. So key to RTLS is what helps in justifying RTLS in a facility is obviously solving the problem of locating items, but you keep in mind that it can be used as a solution for many things over the same infrastructure. So if you were tracking people, whether it be it safety or be it for social distancing, at the same time you could be tracking where your AGVs are. At the same time you could be tracking where your forklifts are, and all this information can be seen on the screen at the same time, or sorted by tag type, etc. So you can, it's important to find as many applications that you can leverage the investment in RTLS and the infrastructure with. Let's show you a couple ideas of how some of our customers are using RTLS today. Many are using them for vehicle solutions, whether it's simply tracking forklifts for safety or collision avoidance, etc., within a facility. And you can do things within location intelligence or Lacera, like look at the traced route over that forklift over the last hour, the last day, the last week, whatever interval that you want to set up. So it's good for that. It's certainly good for locating cars. If you think of a port, like the Port of Long Beach or something, where they're pulling in cars from Asia by the thousands, you'll see pictures of very large lots of cars. And if you needed to locate a specific vehicle, you could put a temporary tag transponder on that vehicle and quickly find it amongst a big mass of cars, or a bus in a bus yard, or the trains in the trains yard, those type of applications. And then RTLS can be used to monitor AGV intersections within manufacturing facilities. And these green light and red light scenarios can be communicated to with the RTLS and help in providing efficient vehicle monitoring and traffic collision avoidance, etc. So good use for vehicles. Another good use is in a general category of logistics. You're tracking parts and raw materials from being delivered in through manufacturing, in and out of inventory, etc. This application is showing both the use of RFID, and you'll see a RFID gateway or portal set up at this loading dock door. And then, if this works correctly, it did not work correctly. There's supposed to be a forklift moving these pallets around, so you could track pallets using either RFID or RTLS, and then of course track the forklift with RTLS because you've got a transponder on the forklift. So it's a nice way to use both technologies, but with the application being logistics. You know, do you lose things? Where are they today? Where are they right now? When did they pass this RFID portal? And get event logs and timestamps on all that sort of activity. We have several tire customers for RTLS in the manufacturing process, I should say, of tires. So everything from, again, the raw materials coming in the door and the mixing processes and the various steps in building tires, curing, testing, finishing, putting those into warehouse and distribution, getting them out the door. This is a great way to use RTLS to keep tabs on a high volume manufacturing process that's constantly in motion. All that information, again, is passed up to the customer's system and translated into the type of information he needs in his MES or ERP system to provide the details you're looking for to best analyze, give you the transparency into the processes used, and to help in identifying whether those processes need to be modified. Personnel locating for safety. This one is a very popular one. You might have in this kind of an oil and gas, I'll call it, application, there might be hazardous areas and you have geofenced areas set up. We have a partner called Guard Hat that puts our transponders in their helmets. And the worker, as they walk around the yard, they know where they're constantly at. If they're in a dangerous area, they can get a tone through the helmet to tell them that you've been there too long or you're drifting back into a dangerous area, please get out of the way. So it's very good for safety and used quite a bit for that. Another good application where we've got customers using RTLS is in automotive. So in the manufacturing process, great example here where we're using RTLS to track tools, and not only where the tools are, but what route the tools took as the worker moved around the vehicle, tightening various nuts in his day-to-day assignments. And there might be different torque settings required for using the tool at a different spot on the car. That can all be affected and changed using RTLS to communicate to the tool. And as the worker moves, the torque can be adjusted to the proper setting for the proper location of the vehicle. Email notifications, push notifications can be sent out so that monitoring that process is done to see if the worker is doing things in the most efficient fashion and has taken the most efficient route around the vehicle, as I said, the tracking capability that we showed earlier. So again, improving the transparency to your overall process and allowing you to gather detailed data and make any necessary changes because of it. Dangerous material handling and supply chain management. So you're looking at, tracking operations here, tracking the dangerous materials used in the operations and attaching an RTLS tag or even an RFID tag to these containers that really eliminate problems in knowing where the chemicals are at any point in time, keeping a record of first in, first out rotation if that's important, knowing specifically which chemicals are next to other chemicals and where they're located in storage. So, eliminating things like reactions and explosions because the wrong chemicals are next to each other. Another great application for RTLS. This is the social distancing application. As I said, it's probably winding down at the moment, but could jump back into contention at any time. But the worker is wearing a RTLS transponder. In this case, it's our 3-inch e-paper transponder, we call it. Its blinks and pings are set up to talk to the gateways. The social distancing algorithm called ctrace is set up with whatever parameters you are comfortable with in your facility, whether it's strictly to CDC guidelines or you want to set up some other distance rather than 6 feet and for whatever specific amount of time before the tags visually flash and give those workers that are in close proximity warnings that they're in a social distancing violation. So that, again, can be done over the same infrastructure that you're tracking forklifts with. It's just a matter of setting up the gateway count to address whatever parameters you want for people being close together. And then seeing the visualization with ctrace and the report capability that it has as part of its software package to give you the details involved in the social distancing situation. Another common RTLS application is keeping track of these tote bins or whatever you want to call these plastic bins. Using the e-paper transponder, different messages can show up on that LCD screen depending where in the process production is, or different signals. It can alert you when something's been added to the bin, when something's been removed to the bin, and give you a nice visual representation of that on these little LCD screens. You can do that in the form of regular wording, QR codes, barcodes, whatever makes sense for what you're trying to track and trace. Here's the bus yard application. I mentioned aligning the buses so that at the end of the day, they're in the proper sequence to leave at the start of the new day. It's a big fleet management chore in the bus yards, apparently. So you're keeping track of when they enter, when they leave. You're helping to manage their position so that they can run more efficiently the next day. And you're also doing things with this transponder. This is the vehicle power transponder. You can do things like send it. It has input-output capabilities. So you can send signals and do things like turn on the air conditioner on the bus so that when the driver arrives in the morning and walks way out to the North 40 to go into bus number 33, it's nicely cooled for him. You can take odometer readings as the bus comes in and out of the yard if you want to keep track of that. So it's a good way within the yard to keep track of those sorts of things in the bus. So it's not meant to track the bus throughout the route of its day. It's simply for yard management type of applications. And here you can see a gateway mounted on an outdoor pole, for example. We'll make this slide set available, and there are some links here that you might want to check out. Some nice, I'm not going to click on the video links, but there's some nice YouTube videos that shows you location manager and location intelligence in action. There's a nice video of that social distancing application at the Siemens Houston facility. And then finally, there's ways to get started with RTLS without deploying coverage for your whole facility. And we offer starter kits and proof of concept kits. I'll let you click on those to see the difference, but there is flexibility in from us in the number of gateways needed to do your proof of concept, to do your starter kit. But it's a very much lower cost way with very aggressive pricing to get a feel, get your feet wet with RTLS, let them run through their paces for a while, and then make the decision, do you want to expand it? It's a very scalable system so that even starting with a few gateways and a few transponders, it's simply a matter of adding more gateways to increase those coverage areas and adding transponders for the number of assets you might want to track. And you might put it in with one application in mind, but remember, you can do multiple applications over the same infrastructure. And that is about it in a nutshell, everyone. Thank you for your time. As I said, we'll make this available so that you have these links to do a little bit more research, but certainly feel free to contact me at any time. My contact info is down there at the bottom, and I'll see what I can do to help you out. I guess, Brandon, we will take any Q&A that might have been popping up. I'm not able to see that in my when I'm sharing the screen there. Brandon, can you hear me? Over. Questions? Let me see if I can do it this way.
Hey, Mike.
Hello.
Okay. Hey, I can ask a question. Actually, I see one here. The question was, what is the battery life like usually for a transponder?
Depends a bit on the transponder type, whether it's the smaller one that we call the asset tag or the e-paper with the LCD screen, and also depends on the ping interval setup and how often that's happening. But you can expect anywhere from a worst case of 6 months to a couple of years, depending on those intervals and how you set it up.
Okay, thank you. There is another question that I see. This is, how do you usually visualize the data, the RTLS data?
The visualization is really a function of the software package that you've elected to use. So whether it's the basic locating manager or location intelligence or Locera, you can see different levels of activity from transponders and translate that into event logs and notifications, depending how much the transponders are moving around. So it's really contingent on the software package you've selected and how you've integrated that up to any existing ERP or MES systems you have in your facility that need stuff presented in a particular way. So there might be further software integration, and that's where we think that Node-RED will help a lot for that.
All right, let me see. Oh, one more. What is the difference between RTLS and RFID? When would I use RFID or RTLS over,
Think of RFID as more straightforward in the sense that you want to know when an asset has, say, entered a room or entered a building or left a building. So there's a stationary set of RFID readers and antennas set up, say, around a doorway. We call it a portal. So you've got an RFID portal, and as something with an RFID tag on it passes by it, you're just simply making a record of entering and exiting. And all that information could be useful, could be all you need, but, the other difference is that tag that's on the RFID, in the RFID application is not powered. Remember, it's a passive tag. So with RTLS, you're constantly seeing where that object is is located. So it's typically, I'll call it a more important asset, maybe a more costly asset, something critical to your operations that you can't take minutes and hours trying to locate. You want to know where it is at any point in time. So it's really RTLS is really a way to get more instant information than RFID.
All right, perfect. That's all I've seen here in the Q&A.
Uli, I think I got my mic back. Can you hear me?
Yes. Mm-hmm.
Okay, sorry about that. My mic dropped off right as I was trying to read out the questions.
Okay. All right. Well, Uli, you got the...
Yeah, great. Well, thank you, Mike and Siemens, for partnering with us on this webinar. Thank you for the education and the insight. And to our guests, we want to thank you all for your questions and your participation. We hope that you found this valuable. And for those of you that did know, that attended, we were providing Uber Eats gift cards for everyone that joined in. So I will be sending you guys all in shortly with the information to utilize the gift card.
Thank you, everyone.
Thank you all.
Bye now.